Hello and welcome. Today we'll be going over section 10.3 on the ellipse. It's another of our conic sections. So first off, a definition, what we mean by an ellipse. So a collection of points in a plane, sum of whose distances from two fixed points is constant. So the idea is, instead of one fixed point like a circle, we have two fixed points. We refer to them as foci, plural of focus. And then all of these points, if I add up distance 1 and distance 2, it's the same no matter where I go in this. You can kind of picture this by taping down a string at two spots and just loosely going around as far as your string will take you. That will form an ellipse. So let's get into building the equation of an ellipse. Without loss of generality, we'll let the center be on the origin, and foci on the x-axis. So the foci are always going to be on the longer side of the ellipse, and an ellipse can be longer vertically or horizontally. This one is going to be longer horizontally. So we'll let their location be negative C0 and C0, and let p equal xy be on our ellipse. Further, we're going to let A0 be a point on the ellipse. Now notice, based on the fact that the second coordinate is 0, this is along the major axis. So in other words, this is right here, right at the end here. So filling in a little bit of detail here. Here is our x-axis, our y-axis. So this guy is at C0, this guy is at A0. And one thing we know for sure, that distance 1 from minus C0 to A0 plus distance 2, distance between C0 and A0, is going to be a fixed value. We'll do distance 1 in blue, distance 2 in red. So our fixed distance, distance number 1, would be A minus opposite of C. since the y's are both 0. Distance 2 would be a minus c. A minus, the opposite of c is really a plus c minus c will drop out. So our fixed distance is 2 times a. So now let's consider that other point, xy, just somewhere arbitrarily on this ellipse, not at a special place on the ellipse like a0 was. So again, distance 1 and distance 2. So our total distance number 1 between xy and minus c0 be the square root of change in x plus c squared, plus change in y minus 0 squared, or simply y squared. Distance 2, x minus c squared plus y squared. So then by substitution, since remember this this total distance is a fixed quantity, 2a then would have to equal the same quantity, x plus c quantity squared plus y squared plus square root of x minus c quantity squared plus y squared. So now you're going to think back fondly to your Math 100 days or your equivalent that you took somewhere else. When you're solving a problem that involves multiple square roots, basically we just kind of get one at a time by itself. So I'll move this n guy over to the other side, and so we'll have 2a minus square root of x minus c quantity squared plus y squared is square root of x plus c quantity squared plus y squared. So this guy stayed on the right, this guy moved to the left side. Alright, so next we're going to square both sides. So then squaring the left-hand side, 2a by 2a will have 4a squared. Then we have minus 2a times the radical minus another 2a times the radical, so minus 4a times the radical that was on the left side, that was the x minus c squared plus y squared. And then negative by negative is a positive, and a square root of something times the square root of that same something will get us out of that square root. So we have x minus c squared plus y squared. And on the right side, we square a square root, we'll have the x plus c squared plus y squared. Alright, so let me get centered here. Alright, let's expand these two guys. Also, I notice I have a y squared on both sides. So we have 4a squared minus 4a times our square root. And let me go ahead and expand that. So x squared minus 2cx plus c squared. And expanding the other side, x squared plus 2cx plus c squared. We get some more cancellation. X squared and x squared, c squared and c squared. Now let's get this square root term kind of by itself. So I'll add the 2cx to both sides. So 2cx plus 2cx is 4cx. I'll move this 4a squared. And we have on the other side minus 4a times our square root. We can drop the 4's now. We can divide both sides through by 4. So minus a times our square root equals cx minus a squared. So once again, we want to get something out from under square root. We got rid of one of our two square roots. So next up, we're going to get rid of the other one by, again, squaring both sides. So opposite of a times opposite of a is a squared. So a squared by x minus c squared plus y squared is worth, and we'll go ahead and FOIL that out. So we have c squared x squared minus 2a squared cx plus a to the fourth. And we'll expand out a little bit more. So a squared by x squared minus 2cx plus y squared. So we're at c squared x squared minus 2a squared cx plus a to the fourth. And distribute. So on our right hand side, we've got our c squared x squared minus 2a squared cx plus a to the fourth. And we do get a little bit more canceling here. We have a minus 2a squared cx and a minus 2a squared cx. So those will drop. So now everything with an x or a y, I'm going to move to the left side. Everything without, I'm going to move to the right side. So let's see, we will keep this a squared that has the x here. Also, the minus c squared has an x squared on it. And let's see, so we'll also hang on to the we have our, forgot my very last term here, a plus c squared in here. So we should also have a plus a squared c squared. My apologies. I didn't finish foiling that guy. He's going to move to the other side. The a squared y squared is staying parked. So we'll have a to the fourth minus a squared c squared. I'm going to do just a little factoring on that right hand side. So a squared minus c squared x squared plus a squared y squared is worth a squared by a squared minus c squared. We're going to let b squared represent the value a squared minus c squared. So then we have b squared x squared plus a squared y squared is worth a squared b squared. And we can divide everything through by a squared b squared. So we have x squared over a squared plus y squared over b squared is worth 1. So if we're centered on the origin and we have our major axis is horizontal, this is basically what will look like. Where notice a squared by definition would have to be bigger than b squared. If we want to shift the center from the origin to say HK, we shift the same way we always have. X minus h squared over a squared plus y minus k squared over b squared is equal to 1. And we could construct a similar idea using the exact same method, but setting up the major axis to be vertical, so we don't have to walk through it again that way. Just basically the bigger denominator would be underneath the y instead of underneath the x. So wherever your bigger denominator is, that one is your major axis, either parallel to the x-axis or parallel to the y-axis, depending on who's larger. Alright, so let's put this to work for us. We're going to find center, major axis vertices, minor axis vertices, and foci. And we'll use all that to do a sketch. So we'll have 16x squared plus 25 times y squared minus 128 times x plus 100 times y minus 44 is equal to 0. So already we can tell this isn't going to be a circle. If it were a circle, we'd have the same number in front of both the x squared and the y squared, or they would have even just divided everything through by that and just had a 1 in front of the x squared and the y squared. So we can tell this isn't just a regular circle. So I like to do a little bit of regrouping still. So 16x squared minus 128x, 25y squared plus 100y is equal to 44. So if we're going to complete the square, we're going to need to factor out the 16 on that one. So leaving us x squared minus 8x. Same deal, if I want to complete the square on the y squared, I need to factor out that 25. So half a negative 8, negative 4, square that, you get a positive 16. 16 by 16 is really a plus 256. So don't forget to take that into account when you're adding to both sides. I wrote down a plus 16, but it was really worth a 256. Same deal here. I'm going to put a plus 4 here, but that plus 4, because of the 25, is really worth 100. So I have 16 by x minus 4 quantity squared plus 25 by y plus 2 quantity squared is worth 400. We divide everybody through by 400. So we have x minus 4 quantity squared over 25 plus y plus 2 quantity squared over 16 is worth 1. So the bigger value for the denominator is under the x's, so I'm going to have a horizontal major axis. Center of my graph, positive 4 for the x, negative 2 for the y. Just keep track of your shifting. Major axis vertices. Basically, if the y were out of the game, if y were worth negative 2, we'd have x minus 4 squared over 25 is worth 1. Clearing the fraction, we'd have x minus 4 squared is worth 25. X minus 4 is worth plus or minus 5. We'd move left and right 5. So moving left 5, you have negative 1, negative 2. Right 5, we have 9, negative 2. Minor axis vertices, we do the same thing. We take out the major axis, so for that one, x would have to be worth 4, and then 0 squared over 25 is out of the game, and we're solving y plus 2 squared is worth 16. So y plus 2 is plus or minus 4. We'd move up and down 4. So our x would stay the same. Moving down 4, we're at a negative 6. Moving up 4, we're at a positive 2. And finally, our foci. Recall from the proof we had that c squared was a squared minus b squared. So here c squared is 25 minus 16. So that is worth a nice pretty 9. So then c is plus or minus 3. We move 3 units left and right from the center. So 3 units left, we're at 1, negative 2, 3 units right, we're at 7, negative 2. Alright, so put all that together and we'll make one nice, neat, pretty little sketch here. Okay, so the center is at 4, negative 2. Major axis vertices, we're going to go left and right 5. So there's the 9, negative 2, and left 1, 2, 3, 4, 5. There's our negative 1, negative 2. So those are the outer edges left and right as far as our ellipse will go. Minor axis vertices, that'll be the top and bottom then of our ellipse. So 4 down to negative 6, so 4 units down. 1, 2, 3, 4 units down, and then 4 units up. 1, 2, 3, 4 units up. And then the foci at 1, negative 2. 3 units left of the center, and 3 units right of the center at 7, negative 2. So then we just connect those guys up with a smooth curve. All right. So we'll take a look at one that is set up the other way. 36x squared plus 25y squared plus 216 times x minus 100 times y minus 476 is equal to 0. So what I'll ask you to do for this is go ahead and see if you can get it into that same format we had before of x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Okay, welcome back. So hopefully you did a little sorting. 36x squared plus 216 times x plus 25 times y squared minus 100 times y was worth 476. You factor to 36, hopefully. Factor to 25 from the next group. So then half of 6 was 3, 3 squared was 9, but 9 by 36 is 324. So you hopefully added 324 to both sides, remembering that we have to take that 36 into account. Similarly, when I put the plus 4 here, it's really a plus 100. So we had 36 by x plus 3 quantity squared plus 25 by y minus 2 quantity squared, and that was worth 30 squared or 900. So 6 squared over 30 squared is 5 squared, so we have x plus 3 squared over 5 squared or 25 plus y minus 2 squared. 5 squared over 30 squared is 6 squared. equals a 1. If you have it as 25 and 36, that's fine as well. Okay, so from this, we can identify our center. That's just shifting the x and y values. So our center is at -3, +2. This time our y had a bigger denominator, so this is a vertical major axis. So that means we're going to shift up and down 6 for our major axis foci, or vertices, my apologies. We'll also shift up and down for the foci. So shifting up 6, we keep the x at -3 and we're at +8. Shifting down 6, x stays at -3, y drops to a -4. Minor axis vertices will go left and right by 5 from the center. So left 5, I'm at -8, +2. Right 5, I'm at 2, 2. Foci, again, they follow with the major axis, so we're going to be moving up and down to figure out how much. Recall c squared is equal to a squared minus b squared, a being the bigger of these two. So c squared is 6 squared minus 5 squared, so c squared 36 minus 25 is 11, so c equals plus or minus √11. So we're going to move left and right by √11 is about 3.3. So, or my apologies, not left and right, up and down, since we have a vertical major axis. So the -3 stays put, the 2 moves up by √11, the 2 also moves down by √11. So that should be enough to make a nice pretty sketch. So our center on -3, 2. And we'll go up and down 6 from the center. From the center, left and right 5. And 2 plus about 3.3. 1, 2, 3 and a third. 1, 2, 3 and about a third. So we just connect up the 4 vertices, the major and minor axis vertices, with a nice smooth curve. And then we have our center and our foci on the graph as well. Alright, so in section 10.3, the homework problems I would recommend. I would try 13 to 67 on the odds, and I'll try to find a rough equivalent for the My Math Lab fans out there as well. If you have any questions, please get in touch. Otherwise, I will see you next time. Stay safe out there.